Welcome to Ms. Crenshaw's first calculus video. Okay, it's really my third one. It's just the first one I'm willing to put out there. And today we're going to talk about curves, and we're going to talk about lines tangent to curves. And this is going to be really brief and to the point. What you're looking at here is a blue function, a purple dot at x equals 0, and a line that is tangent to the curve, and the tangent to the curve is red, and the point just moved around. And the point right here is the purple point. Think about whether the line tangent to the curve has a positive slope, a negative slope, or a zero slope, and what that means about the function. What you see here is another tangent line to the curve. The tangent line is drawn tangent to the curve at the point x equals, and to me that looks about like x equals 1.6. And if I call this function right here, sorry about the slowness, if I call that function f of x, then I could find an estimate for f prime of 1.6 by finding the slope of the red line. And if I wanted to get a good estimate for the derivative of the function, then I would find coordinates for 2 points that are on the red line. This might, this might be a good point to use for finding the slope, and a point like here might be a good point for using to figure out the slope. I try to pick 2 points that are pretty far apart on the line so that I can calculate the slope fairly easily. If you calculate the slope here, you'll find out that it's equal to approximately 5/16. So that's equal to the derivative of f of x at x equals about 1.6. Now we'll look at a few more tangent lines to the same function. Here's another tangent line to the same curve, but the line is tangent to the curve at a different point. See if you can approximate the point of tangency, the x-coordinate. I decided that the point of tangency was approximately 3.8 for the x-coordinate, and so I could estimate what f prime at 3.8 is by approximating the slope of the line that's tangent to the blue function at this x-coordinate. My estimate for that slope, and so my estimate, again that's an equal sign with a dot over it to say an approximation, my estimate for the slope is -1/2, and so that's my estimate for the derivative of the blue function at x equals about 3.8. Decide what the negative sign of the derivative tells you about the blue function. Here are 2 more views of the same function. Look at them and decide which one has a greater derivative at the point indicated, and also determine the x-coordinate for the point of tangency. Here's what I thought. I think these 2 diagrams show that the derivative of f at 1.2 is greater than the derivative of f at 4.7. This concludes our brief discussion about drawing tangent lines to estimate derivatives of functions. Have a great day.